Okay, we're still back in unit number 2. We're working through rates. Actually, I did part of this video already. I just had my microphone on mute and didn't pick up any sound, which didn't help. So I'm going to have to kind of redo some of this. You don't really know that, but that's why some of this is already filled in. We're going to start off with key concepts for displacement. This really should have been done on the previous video, but I'm going to tack it on to this one. So when we talk about displacement, displacement can either be positive or it can be negative. If it's positive, you need to know that it can be one or two different things. It can be either motion that's moving to the right or it's motion that is going to be directed upwards. If it's negative, that displacement can be either to the left or it can mean it's moving down. And, well, how do I know if it's left and how do I know if it's down? Well, that's from the context of the problem. So you're just going to have to determine, well, okay, this object's moving sideways, so it's going to be to the left, or the object is moving vertically, so it'll be moving downwards. So you just gotta have to read the problem and try to figure it out from there, and I think you can do that. All right, rates. Rate is something, when we talk about rate is a question of how fast something is done. So I put fast in a blank. There's all different kinds of ways you could talk about rate. The rate at which you eat, the rate at which you walk, the rate at which you run, the rate at which you do homework. Anything that you do, we can time it, and if we can time it, that's considered a rate. Because we can time it, then we're going to put time in the denominator. So that's the next bullet point. So the units for rate always have time in the denominator. Now there's a great cartoon I have from BC, but you can only see that if you're attending class. All right, the next one, speed. Speed is a rate, so we're going to classify it as a rate. So we've got rate down there already. And so speed is a rate at which distance is traveled. Now we can't put displacement. We'll talk about why another video or two. But for right now, we're just going to put distance, which is correct. Speed also refers to how fast an object is moving. So how quickly you're moving along the ground is basically speed. The abbreviation for speed is a V without an arrow. Sometimes people see V and they think velocity, and that's a pretty good guess. But we're going to learn that velocity has an arrow on top because velocity is going to be a vector and speed is going to be a scalar. And so we're going to use V to symbolize speed. We need to go ahead and record that on our unit sheet, and so I already have done it. I have speed written there, and speed is going to be meters per second. That's the first one that I have written down right here. And then miles per hour, basically any distance over any time. And then there's an equation for it. We'll use this equation for just a brief time in this chapter, and then we're going to slide over and use 3 other equations for speed. But for this one, it'll work now. And speed is equal to distance divided by time. That's just a comma next to it. All right, so back to your notes and where I left off. Speed is a scalar, and that's true because direction is not indicated. All right, now if you were in class, we would literally go outside and I would break you up into 3 different groups. I would break you up into, well, I would choose 2 of you to do some walking. We'd have 2 volunteers to do some jogging and then 2 volunteers to do some sprinting. And we would measure off a certain distance, and usually it's right at about 50 feet. And we would time how long it takes an average person to walk 50 feet. And we would figure that out. And then we would do the same thing for jogging, and then we would do the same thing for sprinting. And then what we would do is we would calculate that speed. So I'm gonna make a guess here. I'm gonna say that let's say we time someone and it takes them, let's say, 5 seconds to go that 50 feet. I'm just making that up. And I guess what I'm trying to do is do the math here that we would normally do in class for this particular problem. So 50 feet in 5 seconds. So we rewrite the equation. So speed is equal to distance divided by time, and that would be 50 feet divided by 5 seconds. We would divide that out and we get 10 feet per second. Now, I'm not real familiar with feet per second. Like if somebody asked me how fast did you travel along the road, well, 10 feet per second. Well, that is, I don't know how fast 10 feet per second is. So we need to make the conversion from feet per second to miles per hour and then to meters per second. We actually need both. So since I'm already in metric, I'm just going to stay in. I'm going to stay in the. I'm sorry. Since I'm already in English, I'm going to stay in English and go ahead and convert quickly to miles per hour. So here's the first one. So I get 10 feet per second. So I know there's 5,280 feet in 1 mile. And if I stopped right here, my answer would be miles per second. I don't want that. But I want miles per hour. So there's 3,600 seconds in 1 hour. And if I divide those out, I'll show you the numbers here. I'm going to 10. Remember, I multiply first, and then I do the division. So don't do it the other way around. If you do it correctly, you'll get 6.8, and that'll be miles per hour. I guess I do want to make that do the mistake real quick so you can see it. If you were to go 10 divided by 5,280 and then multiply by 3,600 without any parentheses, you're going to get a mistake. And so here it is, 10 divided by 5,280 times 3,600. You won't get the same. Well, you do get the same thing. So my calculator actually has that built in. And there are some calculators that do not accommodate for that multiplication down there. So that I'm actually shocked. This calculator does it correctly. So somebody reprogrammed that type of potential mistake at Texas Instruments. So good deal. That's good to know. All right, so we would go through and we would classify some of these. So I've got 6.8 miles per hour, and I know just from experience that that is going to be basically someone that's jogging. So someone that's jogging is basically going meters per second. So I'm just going to go ahead, slide this over, and go 10 feet per second. And I'm going to go from feet to inches, inches to centimeters to meters. I need to get this to meters per second so I can fill in this blank down here. So I know that 1 foot is 12 inches, 1 inch, 2.54 centimeters. We did this last chapter. And then we said 100 centimeters is 1 meter. And I'll go ahead and show the calculations on the calculator. So here it is. So we're going to take 10 times 12 times 2.54 and divide by 100. And we get about 3. So 3, and that'll be meters per second. And from my own experience, I know that if you are jogging, you're going about 2 to 3 meters per second if you're actually jogging. Walking, a typical person walks, these would be things that we'd actually calculate in class, 2 to 3 miles per hour if you're walking, which is about 1 to 2 meters per second. And down here, if you're sprinting, that's about 10 to 12 miles per hour, or about 4 to 5 meters per second. They aren't perfect conversions, but they're relatively close. If you're in class, we would take a look at some images from some Olympic sprinters, and it's actually eye-opening how fast Olympic sprinters actually move. All right, moving along, average speed. This is the total distance divided by the total time. And that's actually what we just calculated. So here's the equation for it. So average speed, sometimes people put a bar above that, and that would be the distance that you travel divided by the time. And distance is measured in meters, time is measured in seconds, so it's going to be meters per second. And there it is.